Welcome everyone. For today's video, we will be looking on how to solve quadratic expressions by factoring. So the general form of a quadratic is normally ax squared plus bx plus c equal to 0. A and b are coefficients and c is the constant. And most times the solution to a quadratic equation often results in two values for the unknown. So the first quadratic equation that we have right here is x squared minus 25 equal to 0. The first thing that you need to do is to factorize. So even though there are two terms, it's still classified as a quadratic. And how can we factorize these two terms? So they don't have anything in common, so we can factor with a common factor. But we can use difference of 2 squared. So in order for difference of 2 squared, we'll have two brackets. So the square root of x squared is x. And the second term that will be in both brackets will be the square root of 25 is 5. And in one bracket, we'll have a plus. In the next bracket, we'll have minus. Here we have factorized. Now, when we want to solve, all we have to do is equate each factor to 0. So x plus 5 equal to 0, or x minus 5 is equal to 0. Our aim is to find what the unknown is. So now we're just going to solve for the unknown. So we have a plus 5, want to get rid of that plus 5, so we subtract 5 on both sides. And now we have x is equal to negative 5. We have a negative 5, so we add 5 on both sides. So x is equal to positive 5. So either x is equal to negative 5 or x is equal to positive 5. So looking at our second problem, we see that neither our first or our second term are perfect squares. Therefore, we cannot use difference of 2 squares right here. But we see that both 3q squared and 147 has something in common. So we can factor out a common factor, which is 3. And when we factor out that 3, we're left with q squared minus 49. So now let's check. So both of these are perfect squares, so we can go ahead and use difference of 2 squares. So I'm going to write back our 3, and we know that we'll have two brackets. In one bracket, it will be minus, next bracket will be plus, and the two terms will be the square root of the first term, so q. Next one, it will be the square root of 49, which is 7. So there we go. So now that we have factorized, we're going to go ahead and solve for our unknown. So q minus 7 is equal to 0, or q plus 7 is equal to 0. So q is equal to positive 7. We want to get rid of the minus 7, so we add 7 on both sides. Or q is equal to negative 7. So q, the value of q is either positive or negative 7. So looking at this, we realize that both terms are not perfect squares. So let's check to see if they have a common factor. We realize that y is common to both terms, so we can factor out our y. So when we factor out our y, we're left with 4y and 7. Right back are equal to 0. So 4y and 7 are not perfect squares, but so we're just going to go ahead and find the values of y. So we see that our y is multiplying by the 4y minus 7. So y would be one of our factor. So y is equal to 0. That is our first value for y, or 4y minus 7 is equal to 0. So we're going to solve for y. First, we need to get rid of this negative 7 by adding 7 on both sides. So we have 4y is equal to positive 7. Get rid of this 4 multiplying by the y by dividing both sides by 4. Therefore, y is equal to 7 over 4, or 1 3/4, or 1.75. So our values for y, either y is equal to 0 or y is equal to 1.75. Let's move right along to the next problem, question 4. Pause the video, attempt the question, and then resume to check your answer. So for this quadratic right here, we have 3 terms, trinomial. So we know that we can't use difference of 2 squared. Let's check to see if there is any common factor, anything that we can factor out. So all 3 terms doesn't have anything in common, so we can't factor out anything. So right here we have to use the AC method. So we need to find 2 factors to replace this middle term right here. So remember that the general form is ax squared plus bx plus c, where a and b are coefficients and c is a constant. So we need to find 2 factors that when we multiply a times c, so a is 1, so 1 times c, which is 15. So we'll multiply those 2 factors, we get positive 15. And when we add those 2 factors, we get negative 8. So I want to find those 2 factors. So what 2 factors will multiply to give us positive 15, but add to give us negative 8? List out all of the factors that we can multiply to get 15. We know that 1 and 15, when we multiply 1 and 15, we can get 15. We know that 3 times 5 will give us 15. So these are the factors that we can multiply to give us 15. So now we need to check. Now 1 plus 5 give us negative 8. No, it doesn't. And does 3 and 5 give us negative 8 when we add them? No, it doesn't. But if we were supposed to make both of these factors negative, then negative times a negative will give us a positive. We'll get the positive 15. And when we add them, adding a negative plus a negative, we'll get a bigger negative. We'll get the negative 8. Therefore, we can conclude that the 2 factors that we're looking for are negative 3 and negative 5. So we're going to rewrite our quadratic, so x squared. And for the middle term, we're just going to replace the middle term with negative 3x and negative 5x. So negative 3x, negative 5x, or write back our c, which is 15, write back our equal sign. So now we're going to factorize. So looking at all 4 terms, we realize that they don't have anything in common, so we cannot factor out a common factor. But we realize that we can pair them and factorize. So we're going to go ahead and do that. So the common factor for x squared and negative 3x is x. When we factor out that x, we're left with x minus 3. And once you factorize the first pair, then that should give you an idea of what the next pair should factorize, so what you should have in the bracket. So you should try to work to get x minus 3. So now what can we factor out so that we have x minus 3 in the bracket? So to get x minus 3 in the bracket, we have to factor out a negative 5. So when we factor out the negative 5, we'll get the positive x minus 3. So here we go. So we factorize the pairs and we realize that both of them have something in common again. So we're going to factorize once more. So we factor out that common factor, which is x minus 3, and we're left with x minus 5. We have completely factorized. We can go ahead and equate. So x minus 3 is equal to 0, or x minus 5 is equal to 0. So we want to get rid of this minus 3, so we have to add 3 on both sides. So x is equal to positive 3, or x plus 5 on both sides. X is equal to positive 5. So those are the 2 values for our unknown, which is x. So we see that we have 27 minus m squared equal to 6m. So before you try to factorize, before you try to do anything, you have to get it in the form, in the general form. So ax squared plus bx plus c. All right, so we see that we have a term on the right hand side, so we need to get rid of that. So by subtracting 6m on both sides, we can get rid of the 6m. and we'll have, so we're just going to rearrange the terms. Our variable square should be the first term, so we're just going to put that at the front. So negative m square. We know that the constant, positive 27, should be the last term. And we have our 6m right here. We're going to just get rid of it from the right-hand side and bring it over. So if we subtract 6m on both sides, it will get rid, so we'll have minus 6m. So there we go, and equal to 0. So now that we have it in the form, we can go ahead and factorize and find what the values for m are. So what two factors, when we multiply, we get negative 27, and when we add them, we get negative 6. So one of the factor has to be a negative factor for us to get a negative product. So the two factors would be 3 and 9. So we'd have to make the 9 a negative, because 3 plus negative 9 would give us the negative 6, and 3 times negative 9 would give us the negative 27. So now that we have found our two factors, we can go ahead and replace our middle term, positive 3m, negative 9m, and we write back our c term. Now that we found our factors, we can go ahead and factorize. We can find the values of m. So therefore, m minus 3 is equal to 0, or negative m minus 9 is equal to 0. So I want to get m by itself, so m is equal to positive 3, because we add 3 on both sides, or negative m is equal to positive 9. So we're not finished, because we have a negative m here. We want to get m, positive m. So we have to divide both sides by negative 1. So m is equal to negative 9. So for our next problem, again, it's not in the right form. So we're just going to go ahead and rearrange before we do anything else. So looking on this right now, we have two options. Because if you realize, you see that the first term and the last term are perfect squares, and the middle term is twice the product of a times b. So a is equal to 6r, b is equal to 1, and the middle term, 2 times 6r times 1 will give you 12r. So this is a perfect square trinomial, so we don't have to go through the stress of finding the two factors and factorizing. We can go ahead and just write it. So we know that for perfect square trinomials, that it is a plus b all square, a minus b all square. So because we have a minus and a plus, we know that it will be a minus b all square. So a is 6r, b is 1. So in this case, both of the factors, both factors are the same. So let's go and find that one value. So 6r minus 1 is equal to 0. We're going to get rid of that negative 1. So we add 1 on both sides. So we have 6r equal to positive 1. We want to get rid of the 6, so we divide both sides by 6. Therefore, r is equal to 1 over 6. So looking at this, chances are you'll start to get stressed, because this is nothing like the other questions. How do we work this out? But it is very simple. So we realize that we have some like terms right here. So we're going to try to first get everything on the left hand side, and then we're going to try to simplify. So we write back our 3x squared minus 2x. We're going to try to move this negative 3x, right, or minus 1, and we want to move this positive 1, so it will become minus 1 equal to 0. So we have some like terms right here, so we're going to go ahead and simplify those like terms. So 3x, negative 2x plus 3x gives us positive x. Negative 1 minus 1 gives us negative 2 equal to 0. So now we have our quadratic, which is 3x squared plus x minus 2 is equal to 0. So perfect square trinomial cannot work for this because our first term is not a perfect square, neither our last term. So those two factors that when we multiply will give us negative 6 is a 2 and a 3. Well, we see that it's negative, so one of the terms have to be negative. So based on the b, which is positive 1, then we know that is a smaller number that has to be negative. So now we're going to go ahead and substitute our middle term, which is positive x, with both of these factors, so negative 2x, right? So I see that this term right here, 3x squared, that the common factor, it would be easier if I put the 3x, the positive 3x with it, because I can factor out the 3. And we see that the c right here is negative 2, and I can easily factor out a negative 2 with the minus 2x. So I'm going to factorize. Now we're just going to go ahead and find the values of x. So our two values for x are negative 1 or 2 over 3. Our final problem for this video is 2p squared minus 6p minus 20 equal to 0. So looking at this quadratic, we see that there's a common factor. So to make it a little easier, we're going to factor out that common factor. So 2 is a common factor. So we take out that 2, and we are left with p squared minus 3p minus 10 is equal to 0. So factoring out the common factor just makes it easier. We work with smaller numbers. So now we're going to find our two factors that will give us negative 10. And when we add them, we'll get negative 3. So seeing that we have a negative number, again, we know that one of the factor has to be negative. So which two factors will multiply to give us a negative 10 and add to give us a negative 3. So those two factors are 2 and 5. And seeing that when you add them, we get negative 3, then it tells us that the bigger factor has to be the negative 1. So our two factors are 2 and negative 3. So we're going to go ahead and rewrite our quadratic and substitute our middle term with both of those factors. We're going to factorize and factorize again. So now p minus 5 is equal to 0, or p plus 2 is equal to 0. So we're going to solve for the unknown. So to get rid of this minus p, we have to add p on both sides. So p is equal to 5, or p is equal to negative 2. So that is it for today. I hope that at the end of this video, you had a better understanding of how to solve quadratics by factorizing. Remember to like, share, and subscribe, and stay tuned for more educational content.